Hello everyone, in today's session we're going to talk about one of the most important and interesting data structures called array. In today's session we will see what is an array, how it works, what is the time complexity of different operations over arrays, merits and demerits, and the applications of the array. Let's stay tuned. An array is a data structure in order to keep a set of similar items in the memory continuously. It's important to have in mind that all the elements in the array have to have the same data types and we have to keep them in the memory continuously. We will see why these two properties are important. Let's suppose that this is the array and we want to keep it in the memory called ARR1, and it's going to store a set of characters, and we assume that each character needs 1 byte of memory in order to be stored. And this is the memory, this is the address of the memory, and these are the elements stored in the memory, and we assume that the array is in the memory starting from the address of 1000. Then the first element will be stored in the address of 1000, the next one will be stored in the next address because each of them needs just 1 byte of memory. But let's suppose that we have another array like this, and it's going to keep integer values, and each integer value needs 2 bytes of the memory. Then the address of the elements will be like this, that the first element needs 2 bytes of the memory starting from 1000, and then the next element will be stored in the next 2 bytes starting from 1002, and so on. In order to have an access to one item in the array, we use the index of the array, and in most of the programming languages the index are 0 based. It means that the first element is stored at the index of 0, and the index of the last element will be n minus 1 if we have n elements. In order to have access to one element of the array, we need to have access to the location of the item in the memory, and in order to find the address of the memory, we use this formula in which the start ARR is the start of the array in the memory, I is the index that we want to have access in order to read or write something over there, byte is the number of bytes that each element needs to be stored in the memory. For example, for this specific array, if we want to have an access to the third element, note that when I is equal to 2, it means that we want to have access to the third element because the index is 0 base, and this is 0, 1, and 2. And then we will see that if we substitute the information, the start of the array, the index times the number of bytes, we can see that C is stored in the address of 1000, and we can have access to that very fast and easy. And if the array is like this, and each element needs 2 bytes of the memory, again, if we want to have access to the third element, the address of the third element will be 1004. Now we can see why the items should be similar and why we have to keep them continuously. They have to be similar because we need the number of bytes that each element needs to be stored in the memory, and we are using here. If they are not similar, we cannot use this formula anymore. And they have to be continuously in the memory because otherwise we cannot use this formula. And it's very important to be able to use this formula because it provides very fast access to the elements in the memory. We cannot do many operations in the array. Access time is O of 1, as we saw, just we need to calculate that formula. And searching an element needs O of n because we need to check the item with each and every single element in the array in order to find that. Then it needs O of n if the array is not sorted. If it's sorted, we can do it by O of log n, but we will talk about it in the other sessions. Merits and demerits of the array. Arrays are very fast if we want to have access to one element, and we can manage several similar items easily and fast, but they are so slow in search because it needs O of n. And some dynamic operations like insertion, deletion, append is not possible in the arrays. We can fix this problem by using dynamic arrays, and we will talk about it in the next session. Applications of the array: for buffering, usually input and output information we can use arrays. For implementing the other more advanced data structures like queue, stack, tree, and this kind of things, we usually use arrays. And in the function, when we want to return more than one value, we can use arrays in order to do that. That's it. I hope you enjoyed. If you have any questions or suggestions, feel free to contact me. In the next session, we will be talking about dynamic arrays, in which we can do some dynamic operations like insertion, deletion, and append. If you like the video, please subscribe and share it with your friends, and hope to see you in the next session.